what are we doing? We are focusing on the grade 11 3D shapes. In the last lessons, we did cylinders. I mean, these are still grade 11 shapes, and prisms. So those are the ones where we did volume and surface area, volume and surface area. Today, we're going to focus on the newer shapes, which are cones. Think like ice cream cones, but without the ice cream. We have pyramids, and then we also have spheres. And cones and pyramids have this interesting little pointy bit called the apex up here. And so we need to talk about, like, how do we deal with that? Whereas the sphere is kind of like a circle that just kept spinning. Whereas this, we have to think about what is a pyramid, what is a cone. And it turns out that pyramids don't always have to have square bases. They can have, rectangular bases and hexagonal bases. So we're going to talk about that tonight. Give me a smiley face if you have at least talked about this a little bit in your class at school. Give me an unhappy face if you've never talked about cones and pyramids. Just so I get a feel for what I'm dealing. Okay. Don't worry, that's why you're here. If you haven't talked about them, today's your day. All right, so here are, let's start with pyramids and cones. If we look at a triangular pyramid, it has a triangular base, and then it has the pointy apex up there. If we look at a square pyramid, we have a square base, and then we have the pointy apex up there. Now, what you notice is with pyramids, we also have these triangular sides. When you have a triangular pyramid, you have 3 triangles on the outside. When you have a square pyramid, you are going to have 4 triangles on the outside. And you can even have a hexagonal pyramid. 1, 2, 3, 4, 5, 6. So that's a hexagonal base. And then you have, basically the base has 6 sides, so you're going to have 6 triangles going around the outside here. So these are pyramids. And so pyramids are the base shape plus triangles. Cone is kind of just like a pyramid, except it has a circular base. Don't worry, Bukle, it's good that you could join us. So you have this circular base, and then you have the, but the one thing that's different is that you don't have triangles. You have this sort of smooth surface over here. And so that over here, it's a bit easier to deal with the surface area because it's just a bunch of triangles. Whereas here, it's got this smooth bit. Now, the other thing that makes pyramids and cones a bit more exciting is that they have a right angled triangle kind of going through the middle of them. So I'm going to try and show you what I mean. Like here, you can see that, imagine this is the middle point, and you go, there's a right angle triangle that cuts through the shape. This is called the true height. And then this over here is called the slant height. We use the letter S. And then this is often referred to as the radius. You can kind of see in this shape more like why that's the radius. That's the true height, and it's perpendicular to the ground. And then this thing over here, the hypotenuse, is called the slant height. Now, those are some new weird words, but give me a thumbs up if you kind of understand this idea of a right angle triangle being inside of a pyramid or a cone. Just give me a thumbs up if my drawings are helping you kind of understand the basic shape. Okay, fantastic. Now, here's the thing. To find the volume of these shapes, it's wonderfully simple. It's just 1/3 times the area of the base. Now, that could be a square, a triangle, a circle, and then times the perpendicular height. So let's just see where that would be. So if I wanted to find the area of this cone, it would be 1/3 pi r squared, because this bit is pi r squared. And then it would just be this thing over here, which is the perpendicular height of the shape. So that would just be that there. Now, if they don't give you all that information, you may need to use Pythagoras to work out some of that stuff. So you may need to use Pythagoras if they give you like 2 of these sides, or they give you like this side and that side. then you may need to work out that side using Pythagoras. But that's not too bad. Okay, so what do you need to write down in your books? For the area of these shapes, 1/3 times the area of the base times the height. Let's do a question together. All right, so this says here, find the volume and surface area of the pyramid with height 3√2. So I'm just going to go 3√2 and point out where that is, and a square base with sides all 6 centimeters. Now, since they said it's a square base, I'm going to remind myself that it's square by putting these things on here. And you know what? I'm even going to write 6, 6, 6, 6. I want you to find me the volume of this square pyramid. So you go ahead, you find that volume for me. What are you going to get? Welcome to Akwande, Alexa, Asande, Bukle, Callan, Ganlin, Koketso, Livu, Machadiso, Naledi, Njabulo, to Nawe, Reniwe, Tenda, and Tandiwe. It is awesome to be with you today. What is the volume of this pyramid going to be? Pop your answer in the chat. This thing over here is the area of the base, and this is the perpendicular height. So 1/3, the area of the base, it's a square, so it's 6 times 6, and the height, they give it to you, it's 3√2. What do you get if you put that in your calculator? So, Reniwe, yes, let's go to you. Reniwe, what do you get? Can you hear me, Reniwe? Maybe there was just a mix-up there. Oh, let's have a look at the chat. Naledi, thank you for your answer. Let's see if I get the same as you. Naledi's got 50.91. What are you getting at home? What are you finding? It's important to do this yourself. Times 6 times 6 times 3√2. I get 36√2, or, and I do think decimal's better here, 36√2 or 50.91. Now, what are my units going to be? They're not going to just be normal units. They are going to be centimeters cubed. So it's how many little cubes will fit inside here. So volume is cubed. All right. Thumbs up if you followed that first one. Thumbs down if you didn't. Now, we are going to try and find the surface area of this triangular pyramid. Tell me what shapes are going to go into the surface area. Now, remember, the surface area is like the wrapping paper. How much wrapping paper do we need to cover the shape completely with nothing left over? What shapes are going to be involved? Callan, you've nailed it. There's going to be a square and there's going to be 4 triangles. And what's more, because this is a square, all of these triangles, and because this is a right pyramid, I didn't go into that, but in grade 11, you have to have right pyramids. This is, all of these triangles on the outside are the same. So all you need to find is the area of one square and the area of 4 triangles. But or one triangle and times by 4. But there is a problem. there's one problem that I haven't dealt with. Who can tell me the problem that makes the triangles a bit more difficult? Who's going to help me out? I feel like I can get the area of the square. That's easy. That's 6 times 6. I feel like I'm confident there are 4 triangles, but I'm feeling a little stuck about the triangles. Yes. Okay. Now the problem is the triangle that I want is over here, and I know what the base. Okay. So when I deal with triangles, it's a half base, so a half times 6 times the height, but I don't want the height of the actual triangle. I want the height, I don't want the height of the pyramid. I want the height of the triangle on the side. And to get that height, I need to get what's called the slant height. So I'm going to use my friend Pythagoras. But in order to use my friend Pythagoras, I need to know what that blue thing is, BC. What is BC going to be? So because this is exactly in the middle, this has to be 3. So can you work out for me, using Pythagoras, what is AC going to be? Luckily, it's the hypotenuse. So AC squared is equal to that squared plus that squared. Find me what AC is equal to. And then find me what the surface area is. So I need to know what the green slant height AC is. And I can go 3 root 2 squared plus 3 squared, and then my calculator is going to help me. What are we getting for AC? Maybe I should do it on my calculator too. Square root, bracket, 3 root 2, close bracket, squared. Oh, wait. Squared plus 9, or 3 squared. Ooh. What are you guys getting? 27? Let's have a look. We're going to get 18 plus 9, 27. The square root of 27. I get the square root of 27. Anybody else getting that? So, and the way I actually did, I didn't even use my calculator. I just went, look, this is going to be 18 and this is 9. So what that means is that if the green, I'm going to put square root 27 in my formula. Can you please find me the surface area of my square pyramid now, please? So 6 times 6 plus 4 times 0.5 times 6 times square root 27. And we get, what are you all getting for your surface area? Put your answer in the chat. Who is going to share their wisdom with me? Share your wisdom, people. I'm waiting. I've got an answer, but I want to see if anybody agrees with me. I have, oh, I see the same answer coming up on the screen. Naledi, Asande, Tandiwe. Okay, we are all 98.35. Let's just make sure we get our units. 98.35, and the units will be centimeters squared. Okay, so when we deal with pyramids, it's actually not that bad. What's new? A third base times the area of the, times the height. You know what, everyone? They actually give you the formulas in the question. They'll always give you the formulas for measurement, but you need to know how to understand what's going on. And students often, if they don't understand where the formulas come from, they don't really recognize what to do. Okay, here is another question. I want you to find me the volume and the surface area for this pyramid. There's a slight difference, but not much. I want you to go ahead. Let's do the volume first. Find me the volume of this pyramid. And then we'll go on to surface area. Just gonna get some water while you work out those. Now, I see these little markings here. This makes me happy because I know it's a square. So this is 13.2. That's 13.2. Well, not up there, but you get the point. 13.2 here. 13.2. So a third times the area of the base, well, that's just going to be 13.2 times 13.2, or 13.2 squared, times the height. Now I need to go looking. I've got a bit of a problem because last time they gave me this one, which is the height. Does anybody have any ideas for how I can get out of this problem I found myself in? Pythagoras is our friend. Yes, Pythagoras is our friend. So if you think of that, this bit here is just going to be half of 13.2 because of the symmetry. This is right in the middle. So 13.2 divided by 2 is 6.6. So that is 6.6. This is 22.4. Can you please help me find, sometimes they call it big H for the height there. Help me find big H there. And then once we have big H, we can then go and find the volume. Who's going to help me with H? So I'm just going to be careful now because 22.4 squared is equal to H squared plus 6.6 squared, and that's by Pythagoras. But now I need to get this H by itself. So it's actually going to be H is equal to 22.4 squared minus 6.6 squared square rooted. Who has an H for me? Square root 22.4 squared minus 6.6 squared. And I get a bit of a messy number. I get 21.41 if I round off. In fact, let's round it off to 21.4. Anybody agree with me? Oh, Okay, thank you so much. Anyone else, just to make sure, can I have a seconder? Thank you, Machadiso. Thank you, Tandiwe. Naledi, I appreciate it. So I'm feeling confident. What is my volume going to be? I'm just going to take this 21.4. Thank you, Koketso. And I'm going to plug it in there. So what's my volume going to be? So Bukle, we normally wouldn't, but because they already had one decimal place here, I'll say that for here it's fine. Generally speaking, you would carry those decimal points. It's a bit of a gray area, actually. I'm not going to worry too much about it right now. For this question, since they've got one decimal point, I'm going to stay there. Okay, so what is my volume? Let's go. We've got 1/3. There will be a little bit of difference if you round off. I wouldn't stress too much about that right now. Times 21.4. Times that. I get a volume of 1242.9 centimeters cubed. Now, that is perfect. I want everyone to now try and find me the surface area of the square pyramid. Can you find me the surface area of the square pyramid? Okay, what are we getting for the surface area? Well, luckily we've got a square and 4 triangles. Now, the triangles will only be identical if it's a square. If it was a different shape, then you have to check. But I think we get 13.2 times 13.2 for the squares. We get 4 times a half times the base. Now, the base of the triangle is 13.2. Now, what am I going to use as the height of the triangle? Can anyone tell me what am I going to use as the height of the triangle in the surface area formula? (22.4) because that's actually the thing we're interested in. So there, slant height. And now I need a final answer for my surface area. What are you all getting for the surface area of this shape? Let's see what I get. 13.2 squared plus 4 times 0.5 times 13.2 times 22.4. I get 765.6, and the units will be centimeters squared. That's how many little squares you need to cover the outside of the shape and on the bottom. Okay, everyone, it's time to vote on our emoticon scale. Where 0, 5, and 10. 0 is you're very unhappy, like you don't know very much. 5 is I kind of know what's going on, but room for improvement. 10 is like rock and roll. Where would you put yourself so far on finding surface area and volume for a pyramid and cones and these types of new things? Okay, now for those who are obviously, if this is the first time you've seen this, it's going to be quite a lot of information. All I want you to do is give yourself a break and come back and re-watch this lesson. Maybe even at double speed, but re-watch this lesson so that you have your brain has a chance to digest it. The main ideas that I'm pointing out is for volume, it's a third times the area of the base times the height, where the height is the height of the pyramid. For surface area, it's more about what is the area of the base by itself, and then how many triangles are there on the outside. And then this new thing called the slant height seems quite important when we deal with the surface area. Okay, so that's what we've done so far. What we're going to do now is we're going to take a little break, but because we've got a little bit extra time today, I'm going to push in the second half. I'm going to push till about 35 or 40 minutes past 6. So we'll have a little bit of extra time in the second half of the lesson today because there aren't any extra student questions. But before we do that, let us all stand up, step away from our tables or our desks. You have a brain, and your brain is connected to your body. And if you upset your brain, it fights back. So let's not upset our brains. Let's keep our brains happy. So we're going to start with 3 deep breaths. Breathe in. Breathe in. Breathe in. One more deep breath. Okay. Then we're just going to loosen our arms up a little bit. Give them a good shake. Actually, let me turn them. Is that too bright? Shake your arms up. Shake this arm. Get nice and loose. Shake your legs. Shake your legs nice and loose. And let's roll the shoulders. Just roll them back. Roll your shoulders forward. And then give yourself another shake, whatever you can shake. And just get nice and loose. The reason we do this is our body gets less stressed and less anxious when we're sort of free. And then our brain's like all relaxed, and it can help us do maths well. Okay, last thing we need is some blood flow. To get some blood flow, we're going to jump around a bit. We're going to do my favorite jumping jacks, and we're going to do 15 of those in 3, 2, 1. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we are good to go. All right, everyone. How are you feeling on a scale of 1 to 10? How awake do you feel now that you've had your mini exercise break? Are you a happy face? Are you a tired face? I actually feel fantastic. I think these breaks are so good for my concentration. I hope they are as good for you. Yeah. All right, let's go back to part 2 of the lesson. So this over here is a cone. Think ice cream cone. Now, the good news is my ice cream cone obeys the same rules as my pyramid. Just has slight differences. So let's start with you. Find me the volume of this cone. So the formula we were using before had a third. Oh, what's going on here? A third times something times perpendicular something. So the area of the base is a circle. So I think I can upgrade this formula to pi r squared, and then this Well, actually, I can see the height of the cone is that. So that's going to be 8. And then what goes in for the R, it's going to be 4. So what is my volume? Pop your answer in the chat if you can already know it. If you don't, I will be along shortly. So times pi times 16 times 8. And that gives me 134.04 centimeters cubed. Oh, this is actually not so bad. Even though the shape looks funky, this is not so bad. Now, where things will get a little bit more exciting is the surface area, but not really that much more exciting, because I'm going to help you. So to find the surface area of this shape, there's clearly going to be a circle. But now we need to talk about this thing called the lateral surface area. So maybe what I will call, well, if you see like this part, how do we describe that part? And this is where they're going to give you the formula, but you just need to understand what it means. So the formula for a cone is pi r squared, no surprises, that's my circle, plus pi r s. What do you think the S stands for in this formula, from what you know of what we've done so far today? What do you think the S stands for? Slant height. Yep, nailed it. So if you look at this shape, it also has a slant height. And so you need to work out what is that slant height. In this case, the slant height will be AB. Once you know what that is, you can use this formula, pi r squared plus pi times r times s. You just need to work out what s is. Okay, so please find me what AB or the slant height is using our friend Pythagoras. You will be given this formula in the exam if they ask you a question, but you just need to know what S is. You need to know it's not the main height of the cone, it's the slant height. It's the diagonal on the side. So luckily they gave me the 4, so that's quite easy. Oh, it's the hypotenuse, so that's not so bad. So I would say S squared is just the square root of 8 squared plus 4 squared by Pythag. And you know what? I'm not even going to put it in decimal. I'm just going to say that's 64, that's 16, that's square root 78. So as long as I haven't done anything stupid, 64 plus 4. Oh, I have done something stupid. So that's 64, that's 16. I think, give me a thumbs up if you get square root 80 as your slant height. Okay. Awesome, awesome, awesome. So now we put a square root 80, and what are you getting for your final surface area of your ice cream cone? No ice cream, just the cone. 16 times pi plus pi times 4 times square root 80, and we get 162.66 centimeters squared. So there's a lot of similarity between the cone and the pyramids, and so that actually makes life a bit easier. Give me a thumbs up if you could follow that example. Give me a thumbs down if you couldn't. Again, be honest, because remember, I can't see your body language. I need to see the people's emoticons to know how you are feeling. Thank you very much. Okay. Well, why don't you find me the volume and surface area for this cone? Find me the volume and surface area for this cone. Can you remember from the early examples without looking back? So 1/3 times the area of the base. This will be pi r squared, and I can see the times 12. So that's actually just a straight plug in the formula. 1/3 times pi times 5 squared times 12. I get 314.16 centimeters squared. Okay, so volume seems like the easier one. Now you're going to have to work out the surface area. How is that going to go? See if you can do that. Now I know there's a circle. So pi r squared takes care of this. But what about this bit? Can you remember how to take care of that bit? I think there was an extra calculation you have to do. I think there is a triangle that you can pull out of this and work out what the slant height is. And the slant height will be whatever that is, which, let's see, 144 plus 25, 169. Oh, I happen to know this one. It's 13. So that is the pi r squared. Oh, what is the formula that I do to incorporate the other bit? It's pi r s, which if I do it like this and I leave a space, it should then be 5, and this should be 13. Now I need my final grand total for the surface area. Plus pi times 5 times 13. What are you getting, ladies and gentlemen? I'm seeing in the chat the same as what I see on my calculator, 282.74 centimeters squared. Let's have another quick vote. On a scale of 0 to 10, how are we feeling about volume and surface area of cones and pyramids? Let the people vote. Okay. All right. Now, again, remember the recordings are always available. Okay, well, since we are mostly okay, what we're going to do is we're going to look at our last shape, which is the sphere. So the sphere, they will give you this formula. The volume is 4/3 pi r cubed. So they will give you that. And so let's just start with a simple question. Here is the formula. Calculate the volume of a sphere with a radius of 3 centimeters. So we are saying that this thing over here is 3 centimeters and it's the radius. Which of the options here, A, B, C, or D, do you think would be correct? In some ways, the sphere is like the easiest one of the lot. Which option do you think it is? Well, I'm going to have to do some maths to figure out for sure. Pi, and then the r is the 3. And then that needs to be cubed. So my calculator says 4 over 3 times pi times 27, and I get 113.097, which would round up to, that would knock that up, so that would be 0.10. And what's more, it's volume, so it would be centimeters cubed. So even though the other ones look tempting, the correct answer is A. Now, while we're doing the volume for a sphere, we may as well do the volume, sorry, not the volume, we'll do the surface area for a sphere. And the good news is the surface area is something they'll give you, and the surface area is just 4 pi r squared. So again, this will be given, but you just need to know 4/3 is about the volume, and surface area is going to be 4 pi r squared. Can you find me the surface area of this particular sphere where the radius is 3? So now I'm talking about the space on the outside. How much wrapping paper would I need to cover it? Can you work out the surface area for me? So let's have a look. 9 times 4 times pi, and we get 113.097, but this time it will be centimeters squared. Now, if I round off 0.97, it's actually going to round off to 113.10 centimeters squared. So the correct answer is actually going to be 113. It's going to be C. Sneaky, sneaky, sneaky. But I think you all understand why that is. Give me a thumbs up if you understand why surface area's answer is C. That was a sneaky question because the volume and the surface area are the same amount. They're just different units. Yeah. Okay, cool. But that wasn't so hard. Okay, let's go to a past exam question to see how we can spice this up a little bit. So it says, and this is what it looks like in an exam question. It says, calculate the volume and surface area of a sphere given below. The radius is 3.5. The formulas are given to you. Find me the volume and surface area for these two. Go ahead. What do you find for the volume? What do you find for the surface area? Okay, well, let's see. Feels like really not too bad. Times pi times 3.5 to the power of 3. And I get 179.59 and centimeters cubed. And then for the surface area, I get 4 times pi times 3.5 squared. and I get 153.94 centimeters squared. Okay, everyone, that wasn't so bad, but now they're going to spice it up a little bit. It says, if the radius is doubled, calculate the volume and surface area of the larger sphere. Actually, that's not so bad. What's the only thing I need to change in order to get the volume and surface area of the bigger sphere? You could leave it as a fraction unless they say round to 2 decimal places. It just depends on the instructions. So the only thing you need to change now is the radius was 3.5. It's now going to become 7. So the volume would just now be exactly the same, except there's a 7 here, and then you get whatever you get. And then for the surface area, it's the same formula, except it's a 7, and you get that. So, I mean, that's the only I'm not even going to go through it now, but you just literally get that by changing the radius. And sometimes they like to see, do you understand what's going on properly? Oh, this is the answer say, okay. Sorry guys, I wasn't much at so you are so much more on the ball than I am. I have used my teacher powers and I've overruled the question. It did say 5 decimal places. And so if I wanted to get full marks, I should have followed those instructions a bit more in detail. Thank you for pointing that out, Machadiso. Okay, now time for a bit of fun. What happens when you take 2 shapes and you put them together? You get a proper ice cream cone. I want you to tell me which of these 4 options. It says a solid shape is formed from a hemisphere, which is half a sphere, and a cone with a radius of 2. The height of the cone is 7. So if you imagine that thing there and that thing there are happening, they're saying the height, this thing is 7. Oh, although the height of the cone, yes. Oh no, but I wonder. Okay, there's some debate. Do they mean the 7 all the way up to there? Or do they mean the 7 is up to there? And I'm not sure because the question is a bit ambiguous. But this is going to be a 2. If we don't find that this works, we'll have to then say, look, this whole thing is 7, in which case, if that's 2, this should be 5. If you know what I mean? Like, so if the 7 refers to that whole thing, then this bit is 2, in which case that bit would have to be 5. And we're going to have to check which answer comes up here. Okay. See if you can give that one a go. I might have to try both ways just to. So you need a hemisphere and you need a cone, and then you need to add them together. You know what? I'm actually going to, I think what they mean is they mean this whole thing is 7. So if that's 2 and that's 5, I'm going to try that first. If it doesn't fit, it doesn't fit. Okay. So the hemisphere, its volume will just be 4/3 pi 2 cubed. And then because it's half, I'm going to divide by 2. Now for the volume of the cone, I go 1/3 area of the base times the height. Now I know what the area of the base is going to be. It's going to be pi r squared or pi 2 squared. The only debate now is whether or not this should be a 5 or a 7. Can you figure out which option you think is correct? Let's see what I get for the top one. What do I get for the top bit? So 4/3 times pi times 2 cubed, which is 8, and then it's divided by 2. And so I'm getting about 16.7551 and so on. Now, this part here, okay, so let's have a look. What should I go with? Let's go with 5 first, and then if it doesn't fit, we'll find out now. 1/3 times pi times 2 squared, which is 4, times 5. And that gives me, at the moment, it gives me just 20.94. And if I add those two together, is there anything which is about 36 or 37? No. So they must have referred to this thing as the 7, as in the height is just basically here. This thing is 7. In which case, let's see if that changes this. So 1/3 times 4 times pi times 7 plus, this is giving us 29.32 and so on. Now 29.32 plus 16.75, 16.7551, I get 46.07 or 46.1, which is D. Now that was a toughie. That was a toughie, but we're building up to it. Can I get a thumbs up if you understand how I got to D there? I do need to, bring the heat at the end of the lesson just to build on, but I know that was a toughie, so if you need to, rewatch that part of the lesson. Let's do one more of these combo questions. Okay, so here is an ice cream cone again. An ice cream cone, a half scoop of ice cream is placed on the cone. If the ice cream melts, will it fit into the cone? Or where's the rest of the... you know what? Let's do... Find me the volume of this shape. Find me the volume of this shape. What I will tell you is I will give you the formula 4/3 pi r cubed for the volume of a sphere. And for the volume of a cone, it's 1/3 times area of base times the height. Can you find me the volume of this combo shape? That should be the area of the base. So in the exams, will be given the formulas? Yes. They have to give you the formulas for these shapes. They don't need to give you the formulas for cylinders. So they don't need to give you the formula for a cylinder. They don't need to give you the formula for prisms, right? Like they don't need to do that. They don't need to give you the formula for like simple shapes. But for these ones like pyramids, cones, spheres, they have to give you the basic formulas. But here, for example, you have to modify the formula because this is a hemisphere. So the volume here is actually going to be 4/3 pi, and then it's 3.5 cubed, but you need to divide this by 2 because it's half. It's not a whole sphere. So you have to customize your sphere. Milady, I'm not sure why they don't give you the cylinder formulas. I think you just meant to know them, I guess. I mean, they might, but I've heard teachers say that they have to, the cylinder and the prisms, you kind of have to just memorize. But some schools do it differently. So maybe ask your teacher as to what they're going to do. Okay, what about the area of the cone? We need to add 1/3 times pi r squared, but the pi r squared is going to be pi times 3.5 squared, and then it's going to be times by 10. So let me even get rid of that. Let's just say we're going to add those two together. What is my volume going to be? Oh, Puvindo, why over 2? Okay, this formula is for a whole sphere. But if you look at the shape, this shape is not a whole sphere, it's half a sphere. So I have to divide it by 2. Does that help, Puvindo? Okay. So what is my final volume going to be? It's going to be 4 over 3 times pi times 3.5 cubed. And then I'm going to divide that. Oh, wait, what am I getting? What are you guys getting? I'm making my calculator angry. 4 over 3 times pi times 3.5 cubed divided by 2, and then plus 1 over 3 times pi times 3.5 squared times 10. And what are you getting for your final answer? I am getting, I'd love to see someone else put their answer first in the chat there. Is anybody else getting 218.07 centimeters? Oh, sorry, 08 centimeters cubed. Okay, now before, we're not quite done. We're almost done. I promise I'll let you go in a moment. But I want us to find the surface area of this upside down ice cream cone. Now, I will give you some help. I will tell you that the surface area of a sphere is 4 pi r squared. So that's for a sphere. And the surface area for just the lateral surface area. So, well, actually, you know what? I'm gonna give you the whole thing. So, if we talk about this, it's pi r squared plus pi rs. But I actually need to ignore one of the parts of the formula. Why do I need to ignore the pi r squared when calculating the surface area of this shape? Why do I need to ignore the pi r squared part when calculating the surface area of this combo shape? The reason is, everyone, is the circle at the bottom is covered. So because it's covered, when you work out the formula for the surface area of the shape, what you're going to do is there's going to be a part which is just pi rs, which is the part that goes around there. You also need to modify the basic surface area formula for a sphere by going 4 pi r squared divided by 2, because you only have half of that. Okay? So to work out the formula, or to work out the surface area of this whole shape, I need to do that. But there's another thing I need to find. What is the other thing I need to find? I don't have this yet to help me. If you think back to earlier in the lesson, what is the other piece of missing information I need to calculate for the shape? It's the slant height. Yes, it's this bit over here, because that's how I know what the radius is. So can someone please work out for me what is, if that's 3.5, that's 10, what is the slant height? I know I didn't draw it to scale, but All right, so for S, let's use a different color. For S, we're going to get the square root of 10 squared plus 3.5 squared. Square root. So according to my calculator, we get square root 449 over 2. So I'm just going to leave it like that. And then I'm going to sub in to this 4 pi, leave a space for the r, over 2 plus pi times that times that. The r is 3.5. And then this bit here is going to be 449 over 2. Someone help me out with finding the surface area of this shape. So, did I get my slant height wrong? Are you guys all getting square root 449? Let me just check that. 10 point, you guys are getting something different. Why is that working? So everyone, when I type this in my calculator, my slant height is 10.59. And yet I see some people saying 12.21. Do you understand? For those who made a mistake there, can you understand where you went wrong there? Okay. What is my final answer going to be? So 4 times pi times, oh, this should be squared. I left that off. That's not good. 4 times 3.5 squared, and then divided by 2 plus pi times 3.5 times fraction square root 449 over 2. I get 100, and I'm going to check this because Sunday has a different answer. So we need to see if something went pear-shaped. I get 193.47. But I'm going to do it again because I have this funny feeling something might have gone wrong here. Okay, so 4 times pi times 3.5 squared, and then divide by 2. Get that, plus pi times 3.5 times fraction square root 449 over 2. And I get, oh, why is it being funny? Let's pi times 3.5. Plus 4 times. I get 193.47. Oh, it just depends on if you add some decimals. Okay, that's fine. So we're in the right ballpark. So that is centimeters squared. Okay, everyone, that was quite a lot. Now, for those who are feeling a bit overwhelmed, just breathe. Go back and rewatch this lesson, even on double speed. As we look back on what we did today, let's go back to the beginning. We looked mainly at cones and pyramids and spheres. We started by looking at how wonderful the volume is and how easy it is to find. Then we spoke about the surface area and about something called the slant height, and then of the triangle and the height of the actual pyramid. We also spoke about volume and surface area of cones, which was very similar to pyramids. And then we spoke about the sphere, which actually seems to be the easiest shape of them all. Then it got a little bit exciting when we started to put combo shapes together, where we had to recognize how we had to change formulas. Like if they said you're a sphere and we have a hemisphere, we divided our formula by 2. So we custom made our formulas. And then at the end, we were just doing another one of these. So in the last lesson on measurement on a Wednesday, I will do exam questions